This is CPM Calculus Chapter 4, number 113. So here we have a horizontal flag right here. Okay, so this is the flag. Part A of the question says, imagine rotating the flag about its pole and describe the resulting three-dimensional figure. Draw a picture of this figure on your paper. Okay, so if we rotate this flag, it's going to go all the way around and it's going to become a three-dimensional piece, right? If the flag was just a rectangle and we rotate it around, it's going to become a cylinder, right? A cylinder like this, right? But here we have these pieces cut out, right? So inside the cylinder, we have this piece cut out, right? And what that piece cut out is, right, it's a three-dimensional piece and it's a cone. So if I put it upright, it's a cone like this, just like an ice cream cone upside down, right? Or a volcano. But so basically, here's a picture, right, with the inside taken out. Like there's this hole right there. Okay? So this is a picture of it. Let's describe it. So I would say it's a cylinder with a cone shaped gap or hole on both sides. Right? There's the hole, so it's hollow on both sides, and there's just because these two cones are removed. Alright, let's go on to part B. Part B says find the volume of the flag. Okay? Well, the volume of the flag, we know how to find the volume of the entire cylinder, right? If there was nothing removed. So let's do it that way. Let's find the volume of the cylinder and then remove the volume of the cone here and remove the volume of the cone on the other side. So cone 1 and cone 2. And luckily for us, these cones have the same dimension on both sides. So that's the same thing as removing 2 times the cone. Cylinder minus the volume 2 times the volume of just one of the cones because they're the same. Okay? So the volume of a cylinder is just it's pi r squared h. And how we get that is if we put it on its side like this, right? Here is a circle on top with the area pi r squared multiplied by the height, right? We'll do the cone in a second, so 2 times something here. But I want to go ahead and plug that in. What is the radius of the cone? Right, the radius of the cone here. Well, that is, if it's rotating around here, the radius of the cone is this height, right? And what is that height? Well, we don't have it right away, but we could find it. We know if this is a triangle right here, this is a green triangle. We know the hypotenuse is 5. This side is 4. How do we find the missing side of a triangle? It's a right triangle. We just use Pythagorean's theorem, right? 25 is c squared. Here we have 4 squared is 16 plus b squared. Subtract 16 from both sides, we get 9 is equal to b squared. Square root of 9 is 3. So this side is 3. So the radius is 3. So it's pi times 3 squared. I'm going to switch back to red. Times h. H is this height of the cone. Well, that's just the side of the flag, which is 8. So pi times 3 squared times 8 is the volume of the entire cylinder. So minus 2 times the volume of the cone. Well, remember, a cone is just 1/3 pi r squared h, right? So then we have to look at the dimensions of the cone. So here I'm just going to pull out just this triangle, we know that this is 3, 5, and 4 by calculating it earlier. And so here we're creating the cone, right? This is the base of the cone, and these sides go up. And the radius of that cone is 3, right? At the base of the cone is a circle, and it has a radius here of 3. So it's minus 2 times 1/3 pi. The radius is 3 squared times h. The height of the cone is just 4, right? This is the height of the cone, 4. All right, so that's just pi times 9 times 8. 9 times 8 is 72, so that's 72 pi, minus 2 times 1/3. 1/3 times 9, right? 3 squared is 9. So 9 times 1/3 is just 3. 3 times 4 is 12. 12 times 2 is 24. So minus 24 pi. Okay? Let me make sure I'm doing this right. Let's just put it in a calculator. So pi times 3 squared times 8 minus 2 times 1/3 times pi times 3 squared times 4. Alright, so that gives us 48 pi, and volume is not units squared, it's units cubed. Alright, so that's going to end for us finding the volume of the rotated flag region. Ending CPM Calculus Chapter 4, number 113.